Our final talk is Matt Hale. Matt is the CTO and co-founder of Everty, and he's going to tell us about the fantastic blockchain technology and how it relates to this sector.
Thanks, Julian. Cheers. Thanks. Thank you. So Mark, if you think that it's difficult explaining how you work in IoT at a family barbecue, I just have some sympathy for those of us working in blockchain. So today I'm going to be giving you guys a very, very brief overview of blockchain, what the technology is, how it's used in the energy industry, and then finally what role IoT might have to play in all of this. So before we get started, just a little bit of background on myself. So I'm a climate scientist, a physicist, and a philosopher who decided that instead of just understanding and communicating the problem of climate change, I wanted to try to do something practical to help solve the problem. So I'm the CTO and co-founder of Everty, which is a peer-to-peer electric vehicle charging network here in Australia. And I'm also the founder of Divi, which is a blockchain-based energy consultancy focusing primarily on community energy. I was lucky enough to be a UNSW representative at the UN Climate Conference, COP21, in Paris in 2015. And more recently, I've published a Medium article entitled Blockchain, Energy, and ICOs, a new way to fund the energy revolution. So I'm not able to go into great detail about the technical implementation of blockchain, but I would like to get a sense from the audience. How many of you have heard of blockchain? Oh, fantastic. OK, awesome. So given the amount of media coverage over the past 12 months, it's not surprising that many of you have come across the term blockchain. But blockchains and cryptocurrencies are often misrepresented in the industry as being the playthings of money launderers, drug cartels. And these unfortunate misrepresentations cloud the deeper potential of the technology, which is that they have the potential to revolutionize one of the most fundamental aspects of human interaction, and that is the way that we exchange value. So I came across this definition of blockchain online a couple of days ago, and I really liked it, and I wanted to test it out with you guys here today. So it's from a guy called Thomas Glucksmann, and he describes blockchain as an open source value transfer protocol that runs on a distributed peer-to-peer network and secures transaction records through cryptography. Okay, now admittedly, there is a lot to unpack there in that sentence. So let's step it back just a little bit. So Bitcoin, much of this will be familiar to many of you, I'm sure, but for those of you not as familiar with the tech, I'll just dive into it very quickly. So Bitcoin is the most well-known and talked about cryptocurrency and blockchain. And when it came around in 2009, it was able to revolutionize the online payment space because it was able to provide a purely peer-to-peer payments protocol that did not rely upon a central trusted authority. But blockchain technology is about so much more than just peer-to-peer payments. Ethereum, which is the second most well-known blockchain and cryptocurrency platform, is much more dynamic and flexible than Bitcoin. And that's primarily because what Bitcoin can do for payments, Ethereum is able to do for pretty much anything that can be programmed. And the reason Ethereum is able to do this is because it can execute things called smart contracts, which effectively take business logic, package it up in computer code, and execute it on a distributed network, the Ethereum network. So in theory, this allows you to build applications, let's say, for example, in Uber, without needing a central company in the middle taking 20% of each ride fare. Another way to kind of describe the potential of Ethereum is to compare it to the internet. So just as a user, when I take my phone out and search something on Google, I don't have to understand the underlying protocols of HTTP or TCP/IP. In order to realize the true benefits of Ethereum as a user, I don't have to understand how that value transfer protocol works, right? So on the left-hand side of this diagram, you can see the fundamental technology stack of the internet as we use it today. So there's underlying protocols, and on top of that, we have server infrastructure like AWS and Microsoft Azure. On top of that, we have the web browsers like Chrome and Safari. And finally, we have the consumer-facing apps. like Facebook, Gmail, and WhatsApp that you're all familiar with. Now, what Ethereum is trying to do is effectively take the internet and replicate it in a decentralized fashion. So we have the underlying protocol of value transfer being Ethereum, on top of which we're already seeing companies deploying distributed server infrastructure, so peer-to-peer server infrastructure like IPFS. We even have beta versions of distributed web browsers like Mist. And finally, we have a couple of decentralized applications, or dApps, the token sales being the most widely known about and used one so far. So that was a really whirlwind overview of blockchain technology, but I'd really like you guys to keep these things in mind throughout the rest of this presentation. And that is that blockchain technology is capable of creating new kinds of business models, enabling new innovative applications, disintermediating current service providers, but also lowering the cost of existing products and services. Right, so blockchain applications and smart contracts are inherently limited in some sense. And that is because they can only affect that which they can control, right? So any blockchain application that wants to interact with the real world in some way has to grapple with a really difficult question. And that is, how can a blockchain application securely and accurately source and exchange data with the real world? So in the blockchain space, this is generally facilitated by the concept of an oracle, which is a trusted entity that produces verified claims about the state of the world, upon which things like smart contracts or applications can execute some business logic. Now, there are many different kinds of ways to implement oracles, so we're going to dive just a little bit deeper into this. For example, if the information that is required is available online, say on a website, then a simple software-based oracle can extract it from that website and push it through to a smart contract. So an example of this might be an oracle looking up a particular centralized exchange online in order to find out how much one Bitcoin is worth in Australian dollars. Another example might be an oracle accessing the Qantas flight tracking service on their website in order to know whether or not that flight is on time or whether it's been delayed. But this approach has an inherent limitation, and that is that you have to trust the website that's producing that information, right? And so in some cases, it's necessary to have what's called a consensus-based oracle. So in this model, instead of just sourcing information from one website, the oracle aggregates information from multiple sources and through some mechanism comes to agreement about the state of the world. These two companies down the bottom here, Augur and Gnosis, tend to, what they do is basically use the power of prediction market economics and a decentralized network to create really accurate forecasting tools. Now, still in other cases, you might require information from the physical world itself. So maybe information about a particular person or a particular object. And in these cases, you really often need localized measurement in real time. And this is where I really see a great role for IoT to play in this space. So an example here might be needing to know the exact location of a shipping container in order to execute, say, a payment event in a smart contract, or perhaps a car insurance company needing to understand the speed of a driver, let's say, at any particular time in order to monitor how fast they're going. But in all of these cases, it's crucial that you have to be able to trust the ultimate source of this information. Because a smart contract doesn't know if the data is corrupted or not. So it will execute its business logic just the same, but the wrong business outcome will eventuate. So from bringing all of this together, we can create a framework to kind of categorize the trust model of any blockchain application. Now, it is a simple framework, but there are two factors at play here. Namely, is the trust model centralized or distributed? And is it based fundamentally in hardware or software? So placing these factors on axes, we can see we form this diagram, and there are 4 quadrants here. And what my argument is that I think IoT has a role to play on the right-hand side here, as acting as the source of information for hardware oracles. Now, let's have a brief look at the energy industry, or the blockchain energy industry, I should say. these are the major players. And unfortunately, I don't have time to go into great detail on all of them as much as I would like to, but I am happy to answer any questions you might have in the panel discussion. So, Powerledger is a local company, a Perth-based company that is using blockchain technology to build a platform that facilitates new kinds of energy trading. In this model, application hosts, such as retailers or embedded network managers, use the platform in order to trade energy amongst participants. Now, fundamentally, Powerledger relies on a suite of APIs that interfaces with a smart meter at the boundary of the system. So if we look back at our diagram, I think we can place Powerledger here in the bottom right-hand quadrant, because ultimately their trust model is dependent on the information sourced from that centralized point in the system, the smart meter, and that's not necessarily controlled by the user. It's often controlled by the retailer or the metering company, not necessarily acting in the best interests of the consumer. Now, looking at a different player, this is Grid Plus. They're a US-based operator, and they have a completely different approach to the market than Powerledger, because they, instead of trying to enable incumbent providers with new technology, they want to become an energy retailer themselves and undercut their competition by around 50%, they claim, using efficiencies gained in trading using blockchain technology. So these guys have their own independent hardware, and that hardware enables their customers to pay for their energy bills in real time using prepaid credit. So looking back at our diagram, I think we can also place Grid Plus here in the bottom right-hand quadrant, and that's because even though they have their own independent hardware that facilitates this bill payment, ultimately it still relies on a data feed coming from the smart meter in order to make those payments. So really it has the same trust model as Powerledger. Now this player is Solara. They're a new entrant into the market. They're actually a Sydney-based company, and they're in fact exhibiting here at the conference. And for full disclosure, I am consulting with these guys at the moment. Solara is an energy-based IoT sensor network. And Solara places these IoT sensors on individual energy assets, like solar panels and batteries. And the combination of using these sensors and using blockchain technology allows us the physical assets, as well as their yield, to be fractionalized and traded in new and innovative ways. Not only this, but the IoT sensors produce really rich new kinds of data sets that haven't really before been possible in the solar panel industry. And so there are innovative application potential for these data sets. Looking back at our diagram, I think we can place Solara in the top right-hand quadrant here. And that's because their trust model is ultimately not dependent on the smart meter at the boundary of the system, but at distributed points throughout the system itself. And of course, it's still based in hardware, so it's still on the right-hand side of the diagram. Now, broadly speaking, most of the rest of the blockchain energy industry fits somewhere within this lower right-hand quadrant here as well. But there is an exception. In my opinion, some contracts should sit outside of the right-hand side of the grid, and that's because they provide no mechanism by which to reconcile their trading of their digital tokens, which are supposed to represent energy, with the real world. So there is no hardware component to their solution. Now, we're in the Energy and Resources Forum, and this should really start ringing some alarm bells. If you don't have a connection to the real world, you're going to have a problem. So I appreciate that's been a really whirlwind trip through the blockchain and energy space. So I have a few key takeaways for you. And that is that blockchain is potentially a revolutionary technology. Oracles act as the gateway between the blockchain world and the real world. And IoT has a huge role to play as acting as the source of truth for hardware oracles. Finally, trust models can vary widely, even within particular industries. And most crucially, the one point you should take away from this presentation is that in any blockchain application, you have to be able to trust the ultimate source of truth in your system. Otherwise, your blockchain application is based on a lie. So thank you very much. Well, that's a font conversion error.